Hello everyone, I am Dr. Aparna, Associate Professor and Head of the Department of Mathematics and Management Sciences. Today I am going to explain Cauchy's mean value theorem and its applications. The Cauchy's mean value theorem is a powerful generalization of Lagrange's mean value theorem involving two functions. Cauchy's mean value theorem helps to solve integrals involving complex frequencies, allowing for efficient analysis of circuit behaviors in the frequency domain. The statement of Cauchy's mean value theorem is if f from AB to R, g from AB to R are such that f comma g are continuous functions on closed interval of a comma b, f comma g are differentiable functions on open interval of a comma b, f comma g are differentiable functions on open interval of a comma b, g dash of x not equal to 0 for all values of x belongs to a comma b such that f of b minus f of a by g of b minus g of a is equal to f dash c by g dash c. This is the statement of Cauchy's mean value theorem. Now I am going to explain some problems related to Cauchy's mean value theorem. The first question is, verify Cauchy's mean value theorem for f of x is equal to x square and g of x is equal to x cube in closed interval of 1 comma 2. Here, given that f of x is equal to x square and g of x is equal to x cube, given that small a value will be equal to 1 and small b value is 2. So, here f of x is equal to x square. Clearly, f of x is a polynomial function. And also given that g of x is equal to x cube. Clearly, g of x is also a polynomial function of third degree. We know that every polynomial function is continuous and differentiable. Therefore, clearly f of x and g of x are continuous functions and differentiable functions in the given interval. Here, g of x is equal to x cube. That implies g dash x is equal to d by dx of g of x. That is nothing but d by dx of, what is g of x here? X cube is equal to d by dx of x cube. Derivative of x cube is 3x square. Therefore, finally, g dash of x value will be equal to 3x square. So, in the here, but the given interval is 1 comma 2 is the given interval. So, g dash of x value not equal to 0 in the interval, closed interval of 1 comma 2. Therefore, clearly f of x and g of x satisfies all the conditions. Therefore, f of x and g of x satisfies all the conditions of Cauchy's mean value theorem. From the statement of Cauchy's mean value theorem, we have f dash c by g dash c value will be equal to f of b minus f of a by g of b minus g of a. Here f of x is equal to x square and g of x is equal to x cube. Then f dash x is equal to derivative of f of x. That means derivative of x square. Derivative of f of x square is 2x. And derivative of g of x is denoted by g dash x, that is equal to 3x square. F dash x is here 2x, g dash x is 3x square. That implies f dash c is equal to, by putting x is equal to c in f dash x, we will get f dash c is equal to 2c, and substituting x is equal to c in g dash of x, you will get g dash c is 3c square. Substituting these two values in equation 1, we have, substituting the above values in equation 1, we have 3c square, 2c divided by 3c square is equal to f of b. Here what is a? A is equal to 1, b is equal to 2. Substituting a is equal to 1, b is equal to 2 in the right hand side expression of equation 1, we have f of 2 minus f of 1 divided by g of 2 minus g of 1. So here in the left hand side, c one time gets cancelled. This is equal to 2 by 3c times of f of 2 minus f of 1 divided by g of 2 minus g of 1. Therefore, we have 2 by 3c is equal to f of 2 minus f of 1 divided by f of 2 minus f of 1 divided by g of 2 minus g of 1. Now we are going to calculate f of 2 and f of 1 values using the given functions. The given function f of x is x square and g of x is equal to x cube. Therefore, f of 2 is equal to 2 square, that is 4, and g of 2 is equal to 2 cube, that is 8. Next, f of 1 is equal to 1 square, that is 1. G of 1 is equal to 1 cube, that is 1. Substituting these all values in the above equation 2, we have 2 by 3c is equal to f of 2 is 4 minus f of 1 is 1 divided by g of 2 is 8 minus g of 1 is 1. That implies 2 by 3c is equal to 3 by 7. 4 minus 1 is 3, 8 minus 1 is 7. From this cross multiplying, we have 2 into 4, 2 into 7 is 14, 3 into 3c. So 9c is equal to 14. C is equal to 14 by 9. This value is clearly belongs to in the given interval. Therefore, the value of C by using Cauchy mean value theorem is 14 by 9. Now I will explain the second problem using Cauchy's mean value theorem. Problem 2. Verify Cauchy's mean value theorem for the function f of x is equal to e power x, comma, g of x is equal to e power minus x in the interval closed interval of a comma b. Verify Cauchy's mean value theorem for the function f of x is equal to e power x and g of x is equal to e power minus x in closed interval of a comma b. Here, the given function f of x is e power x. Clearly, f of x is a polynomial function. Sorry. Here, the given function is equal to e power x. E power x is an exponential function. Then, derivative of f of x is denoted by f dash x. That is d by dx of e power x. E power x, derivative of e power x is again e power x. Therefore, f dash x is equal to e power x. Clearly, derivative of the function exists in the given interval a comma b. That means f of x is clearly differentiable function. And here, given that g of x is e power minus x, then derivative of g of x is denoted by g dash x, that is equal to d by dx of e power minus x. D by dx of e power minus x is equal to minus e power minus x. Here, g dash of x is equal to minus e power minus x. Clearly, g dash of x is a differentiable function for all values of x in the interval a comma b. Therefore, clearly, f of x is equal to e power x and g of x is equal to e power minus x are differentiable functions. Differentiable functions in closed interval of differentiable functions in open interval of a comma b. We know that every differentiable function is continuous. Therefore, f of x and g of x are continuous functions. F of x and g of x are continuous functions. Here, g of x is equal to e power minus x. Then g dash of x value will be equal to minus e power minus x. That value not equal to 0 for all values of x in closed interval of a comma b. So, therefore, f of x and g of x satisfies all the conditions of Cauchy's mean value theorem. Therefore, from this statement of Cauchy's mean value theorem, we have f dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. G of b minus g of a. From this we have, what is f of d from this f dash c from this statement? Here, f of x is equal to e power x. Then f dash of x is again e power x. From this, f dash c is equal to e power c. And here, g of x is equal to e power minus x. Then, g of c is equal to e power minus c. And g dash of c value will be equal to minus e power minus c. From this, we have f of c value is e power c. Substituting these all values in this first equation, we have f dash c by g dash c value will be equal to e power c by minus e power minus c. That is equal to f of b. Here f of x is e power x. Then f of b is equal to e power b. Minus, what is f of a? Substituting x is equal to a in f of x, you will get f of a is e power a by, what is g of x here? G of x is e power minus x, then g of b, by substituting x is equal to b in g of x, you will get g of b. G of b is e power minus b minus g of a is e power minus a. From simplifying we have, thereby expression can be simplifying, we have e power c by minus e power minus c is equal to e power b minus e power a divided by e power minus b can be written as 1 by e power b minus e power minus a can be written as 1 by e power a. That value will be equal to e power b minus e power a divided by taking off LCM of the denominator term, we have, simplifying, we have 1 by e power a minus e power b divided by e power a into e power b. After that, by simplifying, we have c is equal to a plus b by 2. That c value is clearly belongs to open interval of a comma b. Therefore, from Cauchy's mean value theorem, c value is a plus b by 2. Now I am revising the statement. Suppose if you want to apply Cauchy's mean value theorem, first of all, the given function f of x must be continuous function. Here, f of x is equal to e power x is given. Clearly, exponential function is always continuous function and differentiable function. Here, g of x is also given that e power minus x. Clearly, g of x is also an exponential function. Therefore, clearly f of x and g of x are continuous functions in the given interval. And third conditions of Cauchy's mean value theorem is g dash of x not equal to 0. Here g of x is given that e power minus x. So here g dash of x is equal to nothing but derivative of g of x, that value will be equal to minus e power minus x. For all values of x in the given interval, g dash of x is not equal to 0. Therefore, g of x satisfies all the conditions of Cauchy's mean value theorem. From the statement of Cauchy's mean value theorem, we have f dash c by g dash c value will be equal to f of b minus f of a by g of b minus g of a. After that, substituting all values in equation 1 and then simplifying, finally we will get c is equal to a plus by a by 2. That value is clearly belongs to a comma b in open interval of a comma b. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.